Hi, video 3 in the OpenPnP scripting deep dive walkthrough series. Earlier videos describe what we're doing in detail. In essence, this series shows you how I create more complex OpenPnP Python scripts by working on a project that will eventually let us go straight from a BOM, bill of materials, to a set of automagically configured feeders. At this point, we have a handle on the feeders, and we start playing with OpenPnP parts, mapping the components from a BOM to OpenPnP objects. Let's do it.
Alright, so I've been thinking of playing with the BOM here, but the BOM is a great source of information in terms of which parts we'll be using and how many of each, but I don't really care about the BOM. What I need access to are the actual parts from OpenPnP. So I think I'm going to leave the BOM CSV file object alone, nice and independent. All it knows about is the CSV file, and kind of have some encapsulation, some parent object that holds the BOM and maps each entry to various parts. Now what I'm going to need is to have them treated in order of priority being how many of each we're using in the project. So let's see, I'm going to create a little module here. This is part of the auto, let's say. So let's create a module called parts. Okay, now what it's going to need is this BOM, and to do all the magic of mapping the parts. So let's make this a class. So we're going to need the BOM file name, and from that we're going to create a CSV. We've got the package, we've got the value, and that's the thing. OpenPnP takes my parts here and it just generates from the package and name. So oddly, I've got the package in there twice. I've got it associated here, and I've got it in the name, which is fine by me because it's an easy way to differentiate them. So we're going to basically merge them together. I guess that might be keyhead specific, so maybe do that in an abstract way, but call it, so in this case, we're going to go, and that looks like it would work. Let's just try this. For each entry in this BOM, we're going to try and get ourselves a part and map it, and have a way so we can access it in order of popularity. So let's see. What am I going to be doing with this? Right. So now I need a structure to hold that BOM entry so that we can keep track of the quantity and all that, and the part that it maps to. So, okay. So I got the BOM, blah, blah, blah. No. We want these to be defined, even if the BOM, the parsing is failing. Okay, how about we try this? I'll take my BOM, I will map this thing and see what's inside. Let's go to our REPL here and add something new. Okay. Restart this. Let's have a look. Hey, oh yeah. What was my BOM file name? Whatever. Parts map equals the CSV VM. Alright, so that parsed okay. Let's do a little map. VM.map. Ooh, false. False. Is that possible? Oh, yeah. That didn't work. Of course. Let's see how well. 0. Oh, that didn't work out. Come on. I must have at least one cap in there. Zoop. 0. Okay, we need another bomb. Or how about I just import this project and stop messing around so we can get our parts. I don't want to click this because I want to keep to that package value format, but I do want to create all the missing parts. So let's go for it. All right. Now our mapping should do a lot better. So that's great. Let's see, parts. I should have a bunch of new parts with 0 heights. Oh, look at that, how sad. All these 0402s. So that's really annoying, and I hate clicking stuff. So this is one of these scripts that I have. So let's see here, config part set height. Now I'm going to set all these 0402s to 0.1. So C 0402 0.1. Right. So stuff like that. It's pretty useful because I hate re-entering this data manually. So cool. Now we should have all our parts, and mapping should work a whole lot better. Let's give that a shot. Here, no. Okay. Tube. PN equals PN map. Oh. Okay, so that is not working. That's right. Oh, so something is not going well here. Oh, I'm running out of space. Okay, I'll be right back. I need to do some cleanup here. Give me a second. Okay, made a little room so we can do some stuff here. And let's see. Now I realized that my problem here was two things. This was an integer divide, and I was getting 0 all the time, and I'm actually looking at a percentage, but I'm not using a percentage, so let's call this 100 instead, and that should work out pretty good. Also, let's see, too much room here. Also, maybe I should be keeping track of the not founds. Not found. So we can report on them later. So found the bomb entry, right? Okay, cool. So this should be working. Let's take a quick look and see what's happening up here. .csv. Now, if we go pm.map, we got a success. Show percentage map. Turns out to be 72, so that 70 guess was pretty good. Now, if you look at the not found, I mean, the only reason we should be not finding stuff is things that won't be in the placement file. So as you can see, fiducials are in here, pin headers that are through hole stuff like that isn't actually being placed by the pick and place, won't be found no matter what we do. This one here is a little strange. I'm not sure why it's not found. Was it not imported? I don't know. Let's take a look at that. Let's go with this. The job now has all these parts, and what was it? SOP 50 something something, it's a max blah blah blah. So why isn't that in here? I don't know. That's intriguing and to be investigated. Oh no. This is a KiCad issue that I have every once in a while. Every time I create a new part, let's say U8. I bet you anything that this guy is a through hole. What a piece of crap. Okay, so who else? Anyways, that has nothing to do with this project, but I will have to check that out and make sure that I've got. So this is a good way to double check that everything that should be being placed is being placed. So let's see. I will review this later. For now, let's continue. Okay, so I've mapped most of the components, the BOM entries, to actual parts in the system. Now, the thing is, I don't just want them anyway. I want to be able to parse them by priority, by popularity. So that cap with 37 entries, I want to make sure I place that one before anything else. So let's do a little sort here beforehand. So let's see, sorted parts, and we can use a key here and lambda that thing, parts, and this is going to be a project part, so these things have a BOM entry. We don't need to do that. I already put in. Yeah. All right. Let's try that out. You know what? Maybe I should make this part of the thing here because it's really annoying. So a good trick when I have to redo stuff all the time is just, why not stick it in here and just make it part of my default set of interesting things so I don't have to retype all the time. This makes it a whole lot easier. So let's come out and restart the script. And now PM should be here. Wonderful. PM map. And then what am I doing? Yeah. Let's look at the parts here. So that's pretty ugly. It doesn't tell me anything at all. So let's fix that. This is easy Python stuff. Let's just give it this is supposed to be a way to recreate the thing, but whatever. I'm just going to do this. Okay, so that should look a lot better when we output. Let's restart. Okay, PM map, hooray, PM parts. Oh, look at that. So let's put in the quantity because I want to make sure that they're sorted. Restart. Parts. So 1. Oh, I'm sorting. Yeah, that's not the order I want, but okay. All we need to do is reverse that. So I can't remember. Python has some sort of reverse. Whatever. How about we do this? Let's see what happens. Yeah, map. Yeah, parts. Would you look at that? 37 is first, and then we have 14, and then we have 12. Looks pretty good. Okay, now we've got our parts nice and sorted and mapped. So what do we want to do? We want to go through each one, find a good spot in one of those feed sets, and allocate as many strips as we need for some number. So each of these feeds holds up to, please go away. So we can use this to figure out, okay, so I've got up a certain package. So let's say 0402s. My feed holds up to how many of this package? Oh, 50. So in the case that I have 37 of these tiny 0402 caps, one of those strips could hold 50, but if I want to make 4 boards, I'm going to need some variation. So I'm going to use a combination of this stuff to start figuring out how many of each I need, which means I need access to those CSV file objects, and I need access to the feed set, and I need access to the part map. So we're going to put it all together and see how that goes. So what do we want to do? We want to take that first part, and that's the one that's most important. Find the closest feed, and that's where we need to play with the feed sets there, and assign an appropriate number. So we need a feed set that has an appropriate number of feeds free, which means we have to start focusing on those feed sets and see how we can wrap up the things better than some dictionary of lists. So here we go. Okay, this here is going to require another class. Now the reason I'm doing this in such a kind of roundabout way rather than using just lists and stuff is that I don't want to end up with a bunch of tuples. I've got the feeds by distance and I've got the feeds in sets, and I want to kind of combine the two without having to refer to tuple index 3 for whatever. So each feed set will have the feeds that are related to each other, and somehow I'm going to have metadata about where they are so that I can pick the best available feed. Okay, I want the closest one at any moment that's available. So that meta information, whether it's reserved for a certain part or something, is going to be in one of these parent holder classes, these containers. So the system feeds is just going to be a set of feed sets. So let's just do... Not sure why this dictionary values object thing is iterable but not indexable. It's pretty annoying, but whatever, I'll just do that for now. So now I'm going to get rid of this. Boom. And then, so for feed in, or feed set in sysfeeds entries. If the name distance is smaller than whatever, if there was no home, we're going to give it a new home in the whole system feed thing. Feed it to the whole thing. Sysfeeds. Sweet. Okay. How are we testing this? Feed sets. Let's see what happens. Whoops. F. Yeah, that's what we want. Fs. Feed sets. Group. Well, that didn't work out. Okay, let's clean things up a little bit. How about feed sets? Okay, let's take these out of here. Boom. Yeah. A equals Huzzah! Okay. There's no name. What do you want? Okay, let's try this again. All right. Entries. Okay, that's pretty good. That looks sane. Sets. S equals after feed sets. Okay. Entries. 16 of those, 16 of those, 16 of those. Okay, let's see the FS1. FS1 entries. Schloop. That looks pretty good. 2, 1. And that is our proper feed. Okay. So that looks pretty good. Okay, that's looking pretty sweet. Now, let's move on. Release. Now, one thing to note is that here in the feed stuff, I'm getting pretty closely tied to OpenPnP because I'm dealing with actual objects, feeds and parts and stuff like that. And that's great, but it means that I have to do everything within that REPL shell, which isn't all that fun. So that's the reason I kind of separated these classes out here, just to make sure that I could test them easily without having to deal with a bunch of imports from OpenPnP. So now that we have our feed sets semi-rational and ready to accept metadata, the next step is going to be to get down to our list here, and for each entry in our BOM and our part map here, find the nearest feed that's available. So we're going to have to start figuring out, okay, which is nearest and which is available. So that's what we're going to do now. Okay, so now we're almost ready to do this work. Let's call it map here. And let's see. We're going to need a little bit more info to do this. So we're going to go back to the feed sets and figure out what it is we need as meta information. So let's see. We're going to need a couple of things, namely some meta information for each of these feeds. So instead of adding just the raw feeds, we're going to call this feed info, and it'll basically be a holder for stuff like the distance from the centroid and things like that. So let's create this. Okay, so instead of creating just appending feeds like this, we're going to keep a map of the feeds. Feeds by name. Maybe we don't need both, but whatever. So info, feed info, this feed info. I don't know if we need this doubling of whatever. We'll just keep it in place for now. So now we have a way to append data, something available. We want to keep track of whether these things are in use and from what. So maybe that's not the right way to do it. This thing will call itself available as long as there's no associated part. It knows its distance from the centroid. It knows its name and the feed that we're actually talking about. So here we go. We've got that. So now we're going to have to start playing with the feed sets to put in that metadata. So we could get it various ways, but I'm just going to do it quick and dirty and do that. So we're getting feed sets by name, which isn't all that interesting, but let's see. let's say we have a cap and we want 3 feeds reserved for that. So what we're going to do is say, okay, give me the closest feed that no. Let me know if you have 3 and give me the closest one. So from any given set. So I want the 8mm right. Hey you, do you have space for 3 rows? Or maybe space for this many caps? Yes, I do. Okay, how many rows would that be? Okay, give me the closest one, and then we'll try to find a group that's nearby. So feed sets best name as space for num units of package. Return feed sets. Okay, that means we need a has space for. The meta information is going to have the actual feed CSV entry to be able to map that stuff. So let's see. Back to our CSV files. Okay, we want to associate a feed description to each feed so that it knows what it can carry, what it can hold, and all that stuff. So we're going to be mapping that through, well, basically manually, but from the names. So for wow. Okay. No, I still don't know how to break out of here. Okay. Voila. Okay, so we should have mapped a feed info description, whatever, to each of these feeds. So let's just verify that that actually works, like these. Ooh, oh man, Eclipse, PyDev, whoever's doing this, please stop. So annoying. Okay. No? What? That's feeds. That's 0. Okay, this is going to be super annoying to type, so instead of doing that, I will fix this in here. Let's get rid of this. Get rid of this. Space mapper. .csv. And okay. Huzzah! Get name. Other bug here. It's kind of annoying. Get name, is that really in line 85? Let's find out. Let's look at line 85. Ah, boo. Okay. So that's not cool. So I'm splitting this up for cleanliness reasons, but also basically because it allows me to easily use the main trick and run the module as a program. Okay. Feed sets. That's wonderful. 66. What? That doesn't seem right. Feed sets. 60. Come on. Something's wrong with my distance now. Oh. I broke it. I'm getting the feed. Feed set in the entries, y'all. The entries are these guys. Aye, aye, aye. Tisk, tisk. Can't open, can't open. How's that? Yeah, if. Screw you. Well, that's not helpful at all. If 78. I don't believe you. I don't believe you. Oops. Is it that? Well, where is there an if in my code? This is terrible. What? Okay. Oh, wow. That didn't work. Oh my. Feed sets. 6. That's sane. Okay. So this is a feed set. And entries. These are all entries. B dot feed description. Oh, would you look at that? Okay. Now we have the feed descriptions from the CSV files associated to actual feeds that are actually in sets that are actually in the system. So pretty cool. Now we're going to do the same thing with the parts. I'd like to take each package from the part and have some meta information and give it that package description from the CSV file as well. If I can do that, then I can start playing with the metadata and choosing what goes where and how many we need of each.